So good day again. Welcome back to my video tutorial. So today we will be solving three problems in we equilibrium force systems. So this is problem number 1, number 2, and the number 3. So I got these problems from this book by Ferdinand L. Singer. So page 59 from the book. So page 59, problem 318. So this is 317. So this is the problem 317. So the problem states that the system of knotted cords shown in figure P-317 support the indicated weights. So these two are the weights of this system. So compute the tensile force in each cord. So the book already give the answer. So 846 in A. B has 914, C has 400, and D, which has 207 pounds. So I already draw the problem, so we can start. So first, in this kind of problem, we would like to investigate if how many unknowns are there. So we have 1, 2, 3, and 4. So first, in this point, if we cut this cord here, the C here, if we cut that, and we would like to consider this segment or this portion of A, B, and C. So we have 1, 2, 3 unknowns, which are A, B, and C. But if we consider the point here, so this part here, we will have 2 unknowns, C and D only. So we will start solving from this point. So first, we would like to draw some across here which represent this point. So there. So this is D. This is D, and the C is here. C. This is point C, and the 400 weights. So from here you can see that we have a given angle. So if this is 75, then the remaining here is 15 degrees. So meaning this is 15 degrees, and we have 30 degrees here. So because this is a perpendicular to the line, so the remaining is 60 degrees. So our C is 60 degrees. So as you can see, we have 2 unknowns here. So by summing up forces X and Y, using our scientific calculator, we can solve 2 unknowns with 2 equations. So summation of forces X equals to 0. So again, we will equate this to 0 because we are now in equilibrium force system. So this is a force system. So let's start. 60 negative. So C cosine of 60 degrees plus D cosine of 15 degrees equals to 0. The summation of forces Y equals to 0. So C sine of 60 plus D sine of 15 minus 400 equals to 0. So using our magical scientific calculator, we can just input the values. So we have negative cosine 60, so we have positive cosine 15, and we don't have a constant in our equation 1, so just remain 0. So we have sine 60, then we have sine 15, then we have this 400 will be transposed in the other side of the equation, so we have positive 400, so equals, then just click or press the equal button. So we have the answer for our C. C is just equal to 400, and just press again, so we have 207. So our D is 207.06 pounds. So this is our answer for this part only. So then we already have the C, so whatever is our C here will just be equal to the C of the in this part. So if we make another force system just like this one, so we can solve for the remaining two unknowns, A and B. So we have 60 degrees of C here, so we will put the value of 400 with 60 degrees. So, and our B here, and our A is going here. So the B has 105 degrees, but if we cut or extend this perpendicular line, so if this is 60 degrees here, so it's just 105 minus 60, so this is 45 degrees, so meaning this is also 45 degrees. So now we have this force system. We have 400, so with two unknowns. So just like the other one, we can solve these two unknowns by summing up forces. Summation of forces x equals to 0. So negative A plus B cosine of 45, so equals to 0. Then so 0, then plus B sine of 45, then minus 400 sine of 60. So oops, I forgot to include the x component of the 400. So positive plus 400 cosine of 60 equals to 0. So this is our two equation for this portion. So now we can just put it in our calculator. Cos 45, but also you can just solve for B in this equation number 2. Then whatever is the value of your B here, you can just equate that in our equation 1. But I'm enjoying to using this function of our scientific calculator, so we will just use this. So sine 45 and positive 400 sine 60. So the answer is 546. We have A equals to 546.41, and we have B of 489.90. So this is our answer for the whole for this problem. So if you will compare it with the book, so the book has answer of 846. So wait a minute, so I think I got, oh, my values is wrong because we had 300 here, so I forgot the 300. So my my value of or the equation 2 is lacking of 300 pounds. So again, I will be changing this. So guys, if you are asking, I am solving this in this particular time only. So it is impromptu solving. So we will be always having a short error. So again, we have this. So this is just the error that we have encountered. So 400 sine of 60 plus 300. So the answer is 846.41 and 914.16 pounds. So sorry for that. So if we compare it again, so we have 846, 914, 400 and 207. So 846, 914, 400 and 207. So we got all values for problem 317. So moving on to this next problem. So we have this problem 318. So the problem state that there 3 bars hinge at A and D and pin at B and C as shown in figure P-318 form a 4-link mechanism. Determine the value of P that will prevent motion. So we have 304 here. So this is the figure from the book. Hinge at A and D and pinned at B and C. So this is our next problem. So we are going to solve for this P right here. So just like the first problem, we would like to make two for system, but as you can see, we don't have a given distance here or a height. So finding the angle here and here will be impossible. Or if you know how to solve that, you can also do or solve that. So in my case, I would just like to rotate axis. So in this first, if I cut this figure just here, I will cut this here. So first I will just consider this part or the the left part of the problem. So I will consider this. So now I will be rotating the axis. So maybe I will rotate here. I will make this here my x prime, and this will be my y prime. So also in here I will be rotating this. So the line of P is my x prime, and here is my y prime. So now we can make or do the force system for each point. So first, this is the first or the left segment. So as you can see, this is my x and y. X. So yes. So I have 200 pounds here. So then I have a 75 here. 75 degrees of 200. So I have, the A, not 200, but the chord B A. So BA, it's B going A, so because this is the point B. Then I have 45 degree BC, 45 degree from our 200. So we have BC of 45 degrees. So now we can use or solve for x and y forces. So summation of forces x equals to 0. So BC cosine of 45 plus BA cosine of 75 plus 200 equals to 0. Then summation of forces y equals to 0. BC sine of 45 minus BA sine of 75 equals to 0. So this is our two equations, equation 1, equation 2. So now we can solve for BC and BA using our magical scientific calculator. So just input cosine of 45, positive, cosine of 75, then negative 200, then sine of 45, negative sine 75, then 0 equals. So we have 223.07 negative and negative 163.30 pounds. So if you notice, our values are negative, so it is a compressive force in our in these bars, because negative means compression. So this is a compression forces in our bars. This is the 3 bar. So this is the 3 bars. So we have BC is 223.07. So whatever is the value of BC here is also the value of CB here. So I just use that direction. So next we will be making the second segment, the point C. So this is point C, and I did rotate the axis there, so my P is going here, P, then 45 degree of D, so my D is going here, then my CB, so or the 223, so it's 60 degrees. So here, this is my 223 0.07. So this is 60 degrees and 45 degrees. So as you can see, we have two unknowns and we can still solve it because just like the other problems, we have two equations, x and y. So summation of forces x equals to 0. We have p negative minus d cosine of 45, then minus 2 to 3 cosine of 60 equals to 0. So summation of forces y equals to 0. We have d sine of 45 plus 2 to 3 sine of 60 equals to 0. So we have p and d. So using again, we can solve this. So negative 1, then negative cosine of 45, so positive 2 to 3.07, so cosine of 60. Then we have 0 here. So we have 0 because we don't have p in our second equation. So 0, then we have negative sine 45, negative 2 to 3 sine 60. So we 2 to 3.07. So we have 304.72 and 273.20 pounds. So we have these values. So comparing in the book has 304, so positive it is 304. Still we have the same answer, 304.72. So it became negative because we didn't because this 2 to 3 should be going down because it is a compressive strength. Because from the first answer we got negative 2 to 3, so it means it should be going to the point because it is compressive. So it should be here going down. So if we make it like that, so let's see if what will be our p. So positive, then this will become negative 2 to 3.07 cosine of 60, then positive 2 to 3.07 sine of 60. So as you can see, it became negative, and our so this 2 is it should be, this is negative and this is positive, so this should be positive and this one should be negative, because as we say, this should be going down because it is a compressive strength or force. So that's it. That is our problem number 2. So from the book we have 304 pounds P. So we also have P with 304.72 pounds. So check, we got our P. So our third problem is this one. So to solve this, as the book says, it is a frictionless pulley. So remember this, that whatever is your force or load here, it will be transmitted here with the same value because this pulley is frictionless. So if we have 200 here, so here we still have 200. So the same goes here. This is 400, then this is still 400 pounds. So making a force system in this point. So we have the weight, of course, as the book given in the book. We have this cylinder with 800 pounds in total. So we have 800 pounds here, we have 200 here, then we have 400 pounds here, and we are asked to, so let me read it first. So here, cords are looped around a small spacer separating two cylinders, and each weighing 400 pounds and pass. So this cylinder, this part here has two cylinders with separating two cylinders. So weighing 400 pounds. So in total, because this is 2, so we have 400 times 2 is 800 in total weight of the cylinder. So and shown in figure 319 over frictionless pulleys. So these two pulleys are frictionless. So 200 pulleys to weights of 200 and 400 pounds. Determine the angle theta and the normal force and or the normal pressure N between the cylinders and the smooth horizontal surface. So we have surface or the base here. So we have a normal force going up. So we have N here. So the same goes in our force system. So we have still two unknowns, and this problem can still be solved quite easily. So summation of forces X equals to 0. We have negative 200 plus 400 cosine up. So what is our angle? So that is unknown, so just put it theta here, there. So now, because this equation only has one unknown, we can solve for the unknown. So just derive the equation and we will have so I will derive it slowly or in detail. So 400 transpose this 200, we have cosine of theta equals 200 positive. Then this 400 transpose here or divide both sides by 400 and 400, so this will be cancelled out. Then the remaining will be like this, 200 over 400. Then transpose this cos to the other side, so and by transposing this it will be inverse, so it will be like this. So 200 over 400. So that is our final equation. So our theta is cosine shift cos 200 over 400 is 60. So we have 60 degrees. So this theta here is 60 degrees. So then summation of forces y equals to 0. So we have n. So we have n minus 800 plus 400 sine of 60 equals to 0. So our n is just equal to 800 plus 400 sine of 60. So we have 453.59 pounds. So this is our answer for problem number 3. So the book has an answers of 60, 454. So 60 degrees and 454. So we just has a small difference to the answer of the book. Still we got the correct answers. So still this is correct. So this is correct also, and also these two are correct. So that is my solution in our 3 problems. So this is number 1. So if you notice some error and mistake in my solution and in my explanation, so please don't hesitate to comment down below, so we can avoid it in our next tutorial. So this is number 2. So that is my solution for number 2. Then we have number 3. So this is the number 3. So please, if you enjoy, if you learn something again, so please subscribe. And in our next tutorial, so still in equilibrium force, we would like to solve for maybe solution. So this is not, so this is our next problem. So 322, the Finctra shown. So this is our next problem for the next video tutorial. So if you want to be notified, you must subscribe and hit the notification bell, so whenever I will upload the tutorial of this problem, you will be notified. So that's it. So thanks for watching, and please do subscribe. Thank you.